Hi, welcome all. I am Dr. P. Balasundari, Assistant Professor, PG Department of Mathematics, Seethalakshmi Ramaswami College. In this session, I am going to discuss on basic concepts on real analysis. Before moving on to this topic, we call the number system. The real number system is one of the most beautiful mathematical systems. There are several ways of introducing the real number systems. When we talk about the number system, we start with the set n of natural numbers, 1, 2, etc. n, and then use them to construct larger system consisting of all integers. The integers are then used to construct the set Q of rational numbers. Finally, the system Q is extended to the set R of real numbers. We check the axioms using the properties relating to the addition and multiplication of the real numbers. First, overview of this session. First, fundamental operation on addition, fundamental operation on multiplication, field axiom conditions. Next, some basic theorems on addition. Next, some basic theorems on multiplication. Now move on to fundamental operation on addition. First property, closure property for addition, A1. The set R is closed with respect to addition. That is, if A and B be any two real numbers, then A plus B is a unique real number. That means A, B belongs to R, then A plus B is also in the real number system. Next property, associative law of addition, A2. The operation of addition of R is associative. That is, for each triple of real numbers, A, B and C, we have A plus B plus C equal to A plus B plus C. Move on to identity element for addition, A3. There exists a real number, namely 0, such that A plus 0 equal to 0 plus A equal to A for all A belongs to R. Next, move on to existent property of negatives, A4. Corresponding to each real number A, namely B, called a negative of A, such that A plus B equal to B plus A equal to 0. Next, move on to commutative property for addition, A5. For each pair of real numbers, A and B, we have A plus B equal to B plus A. Next, move on to fundamental operation on multiplication. First property, closure property for multiplication, M1. The set R is closed with respect to multiplication. That is, if A and B be any two real number, then AB is unique real number. That means A comma B belongs to R, then AB belongs to the same real number system. Next property, associative law of multiplication, M2. The operation of multiplication in R is associative. That is, for each triple of real numbers, A, B and C, we have A into BC equal to AB into C. Next, move on to identity element for multiplication, M3. There exists a real number, namely 1, such that A dot 1 equal to 1 dot A equal to A for all A belongs to R. Next property, inverse. Existence of inverse in multiplication, M4. Corresponding to each A belongs to R, A not equal to 0. There exists B belongs to R, such that AB equal to BA equal to 1. Here, B is called the inverse of A. Next, move on to commutative property for multiplication, M5. For each pair of real numbers A and B, we have AB equal to BA. Next, axioms. Distributive of multiplication over addition. Distributive property under the operation multiplication. Multiplication distributes itself over addition. That is, for each triple of real numbers A, B and C, we have A dot B plus C equal to AB plus AC. Next, field. What is meant by field? The real numbers satisfying the properties A1 to M5, M1 to M5 and D form a field. That means closure for addition, associative property for addition, identity property for addition, inverse property and commutative property for addition. Also, closure property for multiplication, associative property for multiplication, identity property for multiplication, inverse property for multiplication, commutative property for multiplication, and distributive property form a field. Example for a field: the set of real number is a field, the set of rational number is a field, and complex number is a field. These are examples for field. Next example, which is not a field. The natural number n is not a field because it does not has an addition identity element 0. Thus, the set natural numbers does not form a field. Next, the integers z is not a field because it does not has a multiplicative inverse element. Thus, the set of integers does not form a field. Next, some basic theorems on addition. Using the addition properties, we have the following theorems. There can exist at the most one identity element for addition in R. Proof: by using property A3, prove the uniqueness. To prove the uniqueness, 0 plus 0 dash equal to 0 dash plus 0 equal to 0. Similarly, 0 dash plus 0 equal to 0 plus 0 dash equal to 0 dash. Using identity property, we prove this theorem. Next theorem, uniqueness of negatives. To each x in R, there corresponds one and only one real number y such that x plus y equal to y plus x equal to 0. Here we using the property A4, inverse property, to prove the uniqueness of negatives. If y1 and y2 be two real numbers such that x plus y1 equal to y1 plus x equal to 0, x plus y2 equal to y2 plus x equal to 0. Here we have to prove that y2 equal to y1. So first we take y2 equal to y2 plus 0. 0 can be written as x plus y1. Again, using the associative property, it can be written as y2 plus x plus y1, which is equal to 0 plus y1. And using identity element, we have y1. Finally, we have y2 equal to y1. Hence the uniqueness of negatives. Next, move on to cancellation law of addition theorem. If x, y, z be real numbers such that x plus z equal to y plus z, then we have to prove that x equal to y. Here we take minus z be the negative of z. Then x can be written as x plus 0 using the identity element property. Again, 0 can be written as z plus of minus z because minus z be the negative of z. Next, using the associative property, it can be written as x plus z plus of minus z. We know that x plus z equal to y plus z. So x plus z can be written as y plus z here. So x plus z plus of minus z can be written as y plus z plus minus z. Y plus z of y plus of z plus of minus z equal to y plus 0, which is equal to y. Finally, we have x equal to y, which proves the cancellation law of addition. Next, move on to some basic theorems on multiplication. First theorem, uniqueness of identity element for multiplication. There can exist at the most one identity element for multiplication in R. Next theorem, uniqueness of inverse element for multiplication. To each x belongs to R, x is not equal to 0. There corresponds one and only one real number y such that xy equal to yx equal to 1. Next, cancellation law of multiplication. If x, y, z be real number such that x z is equal to y z and z is not equal to 0, then we have to prove that x equal to y. Thank you.